Welcome back to Math 109 Plane Trigonometry. In this video, we're going to take a look at the idea of periodic functions and then a couple of examples, namely the sine and the cosine functions. So first, the definition of a periodic function is a function such that f of x is equal to f of x plus np for all x in the domain of f, and also for all n in the integers, and for some p greater than 0. So we don't want to call it a periodic function if p is 0 because, of course, f of x equals f of x for any value of x. But if we have some p that'll work for every x in the domain, then we would say the function is periodic, and that number p is referred to as the period of the function. So that's the idea of what a periodic function is. We're not going to worry too much about that in this course, but we will worry about a couple of examples of periodic functions. We have sine of x and cosine of x. So we're going to take a look at the graphs of each of these. And we could graph this using some values we already know, or we could just look at the base functions and I'll tell you. Now we're usually going to plot these in radians rather than degrees. So let's take a look at pi over 2, pi, 3 pi over 2, and 2 pi. And then on the other side, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So the sine, we start at 0, where that's 0. At pi over 2, it's going to be 1. And in between, we know at pi over 4, it's the square root of 2 over 2. Pi over 3, it's the square root of 3 over 2. And at pi over 6, it's 1/2. So we can connect those dots. And then we're going to continue along that pattern. At pi, we're at 0. 3 pi over 2, we're at negative 1. And at 2 pi, we're back to 0. And we can do the same thing the other way. So we get a function that looks something like that. Now we take a look at the distance between those two peaks. And we see that that distance is pi. And if I drew the graph out further, this would repeat every pi. I'm sorry, that distance is 2 pi. So that means the period here is equal to 2 pi. Likewise, we can do the same thing with the cosine function, which I'll graph in blue. So putting in the points that we know in the first quadrant, at pi over 6, it's 3 pi, or square root of 3 over 2. At pi over 4, it's square root of 2 over 2. And at pi over 3, it's 1/2. I put all that together. and do the same thing in the opposite direction. And I'm going to get a graph that looks something like what I have in blue there. Again, I'm going to measure this peak to peak. So we peak at the origin, and we peak at 2 pi. That's an interval of 2 pi. And I could also go in the other direction. And I again see that we get an interval of 2 pi, so that period is also 2 pi. So the key to remember is that both the sine and the cosine are periodic functions with period 2 pi. The only difference is that the sine crosses through the origin, whereas the cosine has a y-intercept of 1. And both of the functions will range between 0 and 1. We could actually do a more detailed analysis and see that the cosine is simply the sine function shifted by pi over 2. So when we do later stuff with the sine and cosine functions, we only need to work with the sine function. All the properties will be the same for the cosine. So that's this video, graphing the basic sine and cosine functions. In the next video, we're going to take a look at a couple of different transformations that we can do on this function to create more graphs.